the raw elements of a shelter begin on muddy, uneven ground. A solid foundation separates the structure from the damp earth below. He secures the first treated timber beams to the concrete piers. This base grid dictates the structural integrity of the entire build. Working from below ensures fasteners penetrate the thickest part of the joint. The grid layout relies on precise spacing to bear the heavy loads of the insulated panels. Each crossbeam prevents the floor from sagging over time. The foundation must be perfectly level before the real weight arrives. Structural insulated panels provide both the subfloor and the thermal break in a single step. Before securing the sheets, he applies a continuous bead of expanding adhesive foam along the seams. This eliminates drafts that would otherwise steal heat through the floorboards. The foam expands into every void, curing into a rigid, airtight seal. Cordless drills drive long screws deep into the foundation joists. The base platform is locked in. With the floor deck cleared, the exterior shell begins to rise. SIP panels are lightweight compared to traditional timber framing, allowing a small crew to manually hoist them into vertical position. The structural strength comes from the sandwich of oriented strand board and dense, rigid foam core. As each wall segment meets the next, applying adhesive to the mating edges is critical. It creates a unified, load-bearing perimeter. A clean floor ensures the bottom tracks seat perfectly flat against the deck. Custom fitting requires slicing through both the outer sheathing and the insulation. The circular saw glides along a straight edge for a clean, square cut. In the corners, wooden blocking is driven into the hollow channels of the panels. This internal skeleton reinforces the angles where wind loads exert the most pressure. The geometry provides the shear strength. The exposed top edge of the foam core must be sealed and capped. A continuous wooden beam, known as the top plate, is driven into the grooved panel ends. This ties the individual wall sections together into one solid, continuous frame. Expanding foam fills any micro gaps before the timber is driven home. The top plate also serves as the critical anchoring point for the impending roof structure. The perimeter expands piece by piece, locking the interior space away from the elements. Every fastener driven through the face of the board bites into the internal timber spline, creating a deeply rigid connection. Traditional stick framing relies on studs every 16 inches to carry the weight. In this system, the entire continuous surface of the panel acts as the load-bearing element. Before a new section goes vertical, the adhesive is pre-applied while the panel lies flat. This ensures an even, unbroken bead along the entire vertical seam. When the heavy panel is finally tipped up, the foam is compressed, forcing it deep into the joint. There is no room for air to pass. Bare-oriented strand board relies on overlapping strands of wood bound under heat and pressure. While strong, the raw seams remain vulnerable to shifting and moisture. The pneumatic nailer anchors the bottom plate directly through the subfloor into the heavy timbers below. Each strike binds the wall permanently to the earth. The lower connections dictate the plumb line for the rest of the wall. Even a fractional error at the base will compound into a major misalignment at the roof. Cutting matching top beams keeps the crew working in a steady rhythm. As the walls grow higher, the installation demands careful maneuvering to align the upper corners. Gravity works against the heavy sheets until the first few fasteners catch the timber frame. They lock the angle in place. Interior partitions follow the same rigid assembly as the exterior shell. A red spirit level confirms the vertical plane is perfectly plumb. Without absolute vertical alignment, installing doors later would become nearly impossible. The interior begins to take its final shape. Every corner checked is a future problem avoided. Following the window framing, the focus returns to sealing every possible gap. The adhesive foam is the primary defense against thermal bridging. When winter temperatures drop, any unsealed seam acts as a vacuum, pulling heat rapidly out of the living space. The expanding sealant pushes into the rough texture of the strand board, gripping the wood tightly. The walls now stand at their full height, forming a rigid box on the platform. To carry the roof load, a final layer of heavy timber must span the top. Working from ladders requires deliberate balance, as the massive structural beams are hoisted into place. Inside the shell, traditional timber framing takes over for the internal load-bearing supports. A speed square ensures the cross bracing is cut to exact right angles. Meanwhile, the exterior sealing continues relentlessly. Moving the applicator gun steadily upward prevents the foam from sagging before it cures. The header beams above doorways carry immense compressive force from the roof down to the foundation. Thick timber is required to prevent the door frames from bowing over time. The chainsaw makes quick work of the heavy lumber, leaving a rough but highly functional edge. Precision here is about structural support, not fine finish carpentry. Building sections flat on the deck allows the crew to work faster and drive fasteners straight. Once the internal frame is squared and nailed, it takes the combined strength of 3 men to pivot the heavy lumber vertical. Securing it to the top plates integrates the interior skeleton with the exterior shell. The structure transitions from a collection of flat walls into a unified, self-supporting grid. Before the roof trusses can be set, the top perimeter receives a final barrier. Sealing the upper edge prevents moisture from wicking down into the exposed core of the panels. The heavy top beams are then anchored directly through the foam. The cap is now completely locked. The final sheets of strand board sheathe the remaining gaps in the upper gables. Every piece of lumber added to the high perimeter stiffens the structure against lateral wind forces. The foundation is anchored and the walls are fully braced. The house is ready for a roof. Moving to the roof structure shifts the work into a far more precarious phase. The steep pitch is designed to shed heavy snowfall, but it makes carrying large OSB panels difficult and dangerous. The crew must brace themselves against the rafters while wrestling the wide sheets into position. Sheathing the roof ties all the vertical framing together, acting like the lid on a box. It transforms the open timber skeleton into a rigid canopy. Once the panels are tacked down, the interior is permanently shaded from the sky. The gable ends require precise vertical studs to support the exterior siding that will follow. Working high on the narrow top plates demands focus and balance. A pneumatic nail gun rapidly fires long galvanized nails through the structural joints. The expanding adhesive is applied along the angled roof line before the final sheathing goes on. This creates a thermal break right at the peak, where rising heat naturally accumulates. Without this barrier, the roof would constantly leak warm air out into the cold atmosphere. Back on the deck, heavy dimensional lumber is spliced together to create massive continuous spans. The circular saw trims the overlapping joints for a flush fit. Driving heavy screws through the face of both boards laminates them into a single structural beam. These reinforced headers will carry the weight of the sprawling roof across the widest open spans. Chainsaws are brought in for deep crosscuts through the thickest timbers. The heavy framing is joined on the flat subfloor, where gravity aids the assembly process. Using a hammer to sink the framing nails provides tactile feedback, ensuring each fastener seats firmly into the dense wood grain. The complex webbing of vertical studs and horizontal blocks provides critical shear strength. The intricate lattice of the final framing sections requires hundreds of structural connections. Pneumatic nailers dramatically increase the pace, driving 3-inch nails in a fraction of a second. This dense configuration of timber is designed to transfer the immense dead load of the roof. Every block and brace prevents the long vertical studs from bowing under compression. The structure is overbuilt by design, ensuring long-term resilience against extreme weather. The final prefabricated sections are carried across the deck. Lifting these massive wooden assemblies to the upper level requires coordinated lifting and steady ladders. At the peak, the roof trusses establish the iconic pitched silhouette of the home. Working along the exposed rafters, the crew secures the heavy outer panels. The highest point of the build is finally capped and braced. With the structural skeleton complete, the house must be wrapped before moisture can penetrate. The black exterior membrane acts as a one-way breathable barrier. It blocks liquid water and wind from entering, while allowing internal water vapor to safely escape. From the upper rafters, the sheer scale of the protective envelope is fully visible. The deep wooden eaves extend far beyond the walls, protecting the siding from direct rainfall. Over the roof deck, a bright white underlayment is rolled out and stretched tight. This secondary barrier ensures that any condensation forming under the metal roof will harmlessly roll down. Every overlapping seam is meticulously fastened to withstand the high wind shear at the crest. The dark red metal roofing is hauled up piece by heavy piece. Using specialized metal shears prevents the heat damage and rusting that an abrasive saw blade causes. The corrugated profile of the steel panels channels heavy rain swiftly off the pitch. Along the edges, a matching metal trim permanently locks the weather out. Following the panel installation, the roof penetrations are carefully sealed. Red ventilation cowls are anchored directly through the steel ribs. These stacks draw stale air and moisture out of the heavily insulated interior, maintaining healthy airflow. Within the tight thermal envelope, the metal ridge cap covers the final upper seam. The house is now a fully dry, weather-tight system. Back at ground level, the muddy perimeter requires a secondary support structure. Galvanized metal brackets are anchored directly into the outer concrete piers. These heavy brackets will carry the cantilevered load of the new wraparound porch. Because the porch framing sits exposed to the elements, green pressure-treated lumber is used to resist rot and ground moisture. The structural posts are bolted securely against the black vapor barrier of the main house. A red spirit level verifies the vertical alignment of the thick timber columns. If the supports lean even slightly, the entire porch roof will sit twisted and uneven. Precision on the muddy ground ensures a perfect fit overhead. The lower roof frame is joined on a ground tarp to keep the fresh timber clean. Once hoisted onto the structural posts, the shallow pitch of the porch rafters ties smoothly into the wall. Horizontal lathing strips are screwed across fiber rafters, creating a grid to support the final panels. The porch roof receives the same dark red steel as the main peak. A final piece of flashing bridges the gap between the metal sheets and the house siding, directing water cleanly away from the foundation. What began as a scattered pile of raw panels on a muddy lot is now a resilient shelter. The structure is sealed, settled, and ready to stand against the seasons.